Before I start, I just want to make sure that you guys understand. I'm not a YouTuber. I don't do this for a living. I don't care about, making money online. This is really just to help you guys with information so you don't have to spend thousands of dollars and countless hours of testing AI models hoping to get a result that you might not be able to get. Because even after you spend thousands of dollars, you're going to be disappointed or maybe not. So that's exactly what I'm trying to tell you. Now, usually how paid videos or monetized videos work is that they want you to stay on until the end of the video so you get the conclusion, because then they get better views. Let me just tell you the conclusion right up front. So if this is something that you're interested in and the details about my journey, then listen on. If not, then after the conclusion you can just go and you can decide whether this information is useful for you or not. So the conclusion is, as of May 2026, regardless of what hardware you're buying, and okay, that not regardless, because if you spend like $50,000 on hardware, then yes, definitely you can have like an awesome local LLM experience. But I mean, let's just be realistic. If you want to spend a couple of thousands of dollars on hardware, would you be able to run local models and do coding related tasks at a level where you can actually use it for production? The answer is somewhat. And why do I say somewhat? Because yes, you can buy hardware, and I've tried several different hardware. So I tried the regular GPU way, the GPU solution, right? Now, when you just buy GPUs, obviously you have to have like a whole computer. So I put together my own AI computer with motherboard, RAM, and all that stuff. And the key point over here is the GPU, the graphics card. And I don't really like that my computer is consuming so much energy, and also it's generating so much heat. So I had a NVIDIA 4090 and an NVIDIA 3090 put into a machine. They each have 24 gig RAM, and obviously this is not like necessarily the video for like super beginners. I mean, at least you should know what a VRAM is, right? So GPU has VRAM, and the more VRAM you have, the better your experience is gonna be regarding AI inference. So I placed both of these cards into the same machine, and that's all together 48 gigabyte VRAM, which sounds a lot, but that's actually very few. The performance of AI inference is okay. That's actually all right, but the bottleneck is definitely the VRAM. So even if I would put like one more card or 4 cards in the machine, so 4 GPUs, like 4 4090s or something, or 5090s or whatever it is, it's still not enough because the VRAM is the bottleneck. 96 gig VRAM that you can get using 4 cards, you're up to like consuming like 600-700 watt, which is a lot, and you're generating so much heat. You need a lot of space. So this is not where I wanted to go. Oh, not to mention, like running GPUs like this without actually linking them together is not providing the best experience, because each GPU would have to load in model weights separately because there's no unification. So the software has to manage this, which GPU is loading in what part of the model, right? As opposed to having just one GPU that has 96 gig RAM, such as the NVIDIA RTX Pro, like 6000, right? That would be a much better choice. But if you have multiple cards, then you would need to link them together to be efficient. Now, as far as I know, the 3090 that still has the NVLink option. So you could actually have 4 3090s that you can link together, like talking about the hardware. So there's a cable you can connect these cards, and then they all behave, if you're using the proper software, they all behave as if they were one card. Starting with 4090 or wherever it started, this option is not there anymore. 4090 doesn't support NVLink. But regardless, even if it does, this is just not the setup that I'm interested in. This is not what I'm looking for to have a high performance, high power usage for my AI inference. What I'm interested in is something small, something light, and something that doesn't eat too much power. So the next best thing that you can do if you don't want to do the big GPUs is you can buy a small mini PC with unified memory. And there are actually three different choices or options you have. The first option you can buy, and this is the cheapest one by the way, is go with AMD. So AMD has some special AI chip. It's called Strix Halo, AMD Strix Halo. And this chip is manufactured by so many, not the chip, sorry, the mini PC can be manufactured by so many different computer manufacturers, such as GMK Tech, B-Link, and so many others. The price range for these machines is about 2,200, 2,500. Some of them are in the 3,000 range, like the B-Link one. The performance is pretty much the same. Cooling might be a little bit different, but pretty much the same. So I honestly feel like if you go with this option, then it doesn't really matter which one you choose. I personally have the JMK Tech Evo X2 version, and it's pretty good. Pretty good for, and I will tell you what it's good for. Now, unified. So what other computers have unified memory? So you could use the NVIDIA side of things, which is the DGX Spark, right? So that chip, the Blackwell chip, also it's the same way. Like there are a lot of these manufacturers who create these mini PCs. So you can buy the original NVIDIA one, which is the DGX Spark, right? Or you can buy with the same chip, Asus, Dell, for all, pretty much it's the same thing, but different cooling, different size, different quality, but it's speed-wise, it's gonna be the same thing. Now, this is a little bit more pricey, so I actually had the DGX Spark from NVIDIA, and the price was, I believe, close to $5,000, $4,000 or $5,000. And yes, so this is a little bit, it's supposed to be a better option compared to the AMD Strix Halo. It's supposed to be faster. And to be honest with you, when it first arrived, it was faster. I was seeing speeds that I haven't seen with the AMD Strix Halo. But the problem was that the computer was overheating like crazy. I mean, after just a couple of minutes, it was already in the 90s, like Celsius, right? So I was very concerned because the Strix Halo was hovering around like 70, 75 Celsius, so much more thermal efficient. So I was actually considering that I would return the NVIDIA DGX Spark, because I was like, come on, like, this is ridiculous. Like, I will cook the computer after running it like that for a couple of weeks or months. I mean, this is definitely not good for the computer, not to mention it will thermal throttle, right? Because it's just simply too hot. Now, if you don't understand some of these terms, then go look them up. This video is not really about, teaching you all the details. Thermal throttling, yeah, it's a thing. Just go look it up if you're interested. So, the interesting part with the NVIDIA, I was trying to see like what I can do to limit the power, and I started reading you can use the NVIDIA utility, NVIDIA SMI utility to restrict the power. But then, in the meantime, I updated the DGX Spark. It has its own updater. And then after running the update, to my biggest surprise, the performance went down like drastically. I'm talking about like it wasn't overheating at all, but the problem was that it became much slower than the AMD Strix Halo. So basically, I bought the AMD Strix Halo for 2,200, and I bought the DGX Spark for 5,000, close to 5,000, and it's almost, not almost, it's double the price, and the AMD Strix Halo was faster in a lot of ways than the DGX Spark. And now I know that people will say, oh yeah, because I didn't run it properly, right? On the AMD Strix Halo, and by the way, I tested all these different ways of running a model, different engines. So I tested, on the AMD Strix Halo, I was using Llama CPP, but I also tried VLLM and all these other options, which is obviously not designed for AMD Strix Halo, but still I did. I tried Llama, I tried everything to kind of like compare speeds and reliability. On the DGX Spark, I was running VLLM because with VLLM, using the FP8 weights, for example, the hardware, there's like direct hardware support built into the chip that would make it more efficient. So I was thinking like, and then obviously the DGX Spark has to be much faster. So comparing speeds between the AMD Strix Halo running Llama CPP models and the same model on the DGX Spark using VLLM, I was getting better results using the Llama CPP after the update. And let me just say after the update. Before the update, the speed was crazy, but it was heating up like a lot. So after this, I kind of decided that I want to sell the DGX Spark because it's not really serving me. And there's one more thing that I haven't tried, which I was very much interested in, and that was the Macintosh side of things. So on Macintosh, there is the MLX engine, which is supposed to be different and more optimized for Mac hardware than the Llama CPP versions. So I bought a Macintosh, and not just any Macintosh. I bought a MacBook Pro M5 Max chip with 128 gigabyte unified memory. I was really debating whether I should go with the Mac Studio, but the problem is Mac Studio, I have two options. I could have gone with Mac Studio M3 Ultra or M4 Max. And looking at all the performance benchmarks and everything, I kind of came to the conclusion that yes, although I could go higher higher RAM, the unified memory on the Mac Studio M3 Ultra, and I believe the M4 Max as well, but still the M5 chip has some really awesome improvements, such as improving prefill speeds and stuff like that. Once again, if you don't know what prefill speed is, pretty much just, just look it up. Prefill is when you load the information into model for it to respond back, and the decoding speed is when it responds back and it's outputting the information. So anyway, I bought the MacBook Pro, and then finally I was feeling like, okay, this is the hardware, and this is the one that finally I was looking for, and I will be able to run models fast. And by the way, I haven't talked about speed yet. On the Strix Halo, I was able to get about 44, 45 token per sec decoding, and very slow prefill with the Llama CPP. I believe like a couple of hundred token per sec for the prefill. On the NVIDIA DGX Spark, the prefill was much faster, but still after the update, the token per sec, the decoding token per sec went down to like sometimes even 20, 30. And if it went up to the 40s, that was already very good. So overall, it was not a good experience. Okay, so learning from these two, I was expecting that the Macintosh, and also doing some research prior to purchasing the computer, I was hoping that it can go much higher as far as token per sec goes. So I bought the Mac Pro. I loaded in the models just using LM Studio, just the regular GGUF, like Alamo CPP model, just to see like what would be the speeds if I'm just using the same models that I've used on the Strix Halo. And it was not bad. The speed was okay. It was faster, definitely faster than the Strix Halo. I don't quite remember the exact numbers, but it was faster, but not much faster, but it was. So then I was like, all right, let me load in the models using the MLX engine. The MLX, just using LM Studio, was giving me obviously way better performance, but at the same time, I created a small benchmark program that would check the accuracy of the model. Like I was doing this needle in a haystack kind of search. I was feeding the model with 4K context. I was keep giving it 4K more. How do you say, keep increasing the context by 4K, and then checking and reading back, like asking back information from each context that I fed it previously. It's kind of like a needle in a haystack. And what I noticed that the GGUF model was more stable and more accurate than the MLX one, but the MLX one was way faster. So after that, I was like, all right, I heard a lot of rumor and a lot of news about some models performing much better with MTP, like multi-token performance and multi-token prediction feature enabled. And I think just recently Gemma 4 came out. They came out with a drafter model, which is a much smaller model, and it basically enables the main model to use the smaller model for prediction, but the big model would then verify the smaller model's work. So what they said is it's very similar as far as like quality goes. And then it turned out that Qwen models, like Qwen 3.5, 3.6, they have a built-in MTP support. So it doesn't require an outside drafter model. So it's supposed to be much more efficient. So anyway, I started playing around with things, different engines, because even if you're using the MLX engine on Mac, there are many different ways you can run it. So just recently, for example, Olama started supporting MLX models, and they have their own MLX engine. But I noticed that, Olama's speed and performance was way better than LM Studio, for example. But then I started looking at other things, such as OMLX. And I'll tell you the next one too. OMLX was, wow, okay, now we are talking. So for example, just to give you some reference, so Qwen 3.6 35B MOE model that was giving me like 40 to 45 token per sec on the Strix Halo was giving me 92, 95, sometimes even 100 token per sec for decode. We're using OMLX. I was like, wow, okay, now we are talking. That's completely usable. So then I looked into like how can I make this MTP feature even more more efficient. So I found the project. It's called MTPLX. And then I downloaded it, I installed it. I installed one model that comes like pre-configured, which is a 27 billion model from Qwen 3.6, which is a dense model. So obviously there is a difference between sparse model and dense model, so MOE and dense models. So this was a dense model, 27B, which requires a beast of a computer, but still it's able to run it. And what I've seen is that, wow, the speeds using MTPLX is by far the fastest that I've ever experienced anywhere. So it really shows that it's not just the hardware that you have. really matters what type of models you're using and also what type of engine you're using. So the combination of these three, the the and not just the combination of the three, but actually the combination of the four, because the tool that's using the model can also make a big difference. Just to give you an example, if you're using a tool such as Klein or RuCode or KiloCode for agentic tasks, there is a setting that I believe is called pre-fill cache, not pre-fill cache, prompt caching or something like that, right? You can turn different features on and off, and if you have the prompt caching on, then the model, it should be, things should be much more snappy, or you can fine tune the model using the tool, but then the hardware still limits you, or the engine can still limit you, or the model itself can limit you. Some models don't have the MTP part of the weights built in, for example. So anyway, you have to look at everything together. So what I found so far out of all these experiences, the M5 Max MacBook Pro was using the MTP-LX engine with the, it was providing me with unbelievable speeds that I haven't seen before. With the 27 dense model, which is a huge model for a local LLM, it was giving me 32, 33 token per sec, which is not bad. I mean, okay, being in the 80s and hundreds is definitely a much better experience, but still, it's not bad. It's pretty usable at this point. And if you and I really wanted to try the MTP LX with the MOE model, but I was able to fire it up, but it was not really working fine because I guess it was designed for the dense model. I'm not sure what or why. But anyway, so one thing I noticed, the more I push the computer, the more it gets hot. So with the M5 MacBook Pro, I actually had to do some tweaking. Because, okay, now I have the perfect hardware, and by perfect I mean like, low power consumption, small space, and fast speed. It kind of fits everything. It fits the MacBook is fitting this description, but it was overheating when I was pushing it real hard. So what I did, I ordered some thermal pad, and I opened up the backplate of the MacBook Pro, and I applied some thermal pad between the cover, the lid, and the heat pipes. I've seen this couple of people doing it. I was like, well, this makes a lot of sense because the back plate or the bottom plate or the bottom lid, or whatever it's called, of the MacBook Pro is kind of like trapping the heat inside. So the heat pipe, between the heat pipe and the lid, there's air, and the air traps the heat in. So I was like, okay, by applying the thermal pad, it makes a lot more sense that now the heat will be transferred to the bottom lid. And it did. After I applied the pad, it was much better. The whole bottom side of the lid got so hot that now I understand why Macintosh decided, or Apple decided not to go this route, because for an average user who's actually trying to use the laptop for, like having it on your lap, like it's burning hot. Another concern that I had is that, okay, it's not only burning hot, which I don't really care about as far as like, I'm not going to keep it on my lap. I bought it more like an AI inference server, so I can put it in a box with proper cooling, right? But the issue that I started having, not really an issue, I was even more like a concern, is like the battery can also overheat now much more because the lid is way, way hotter, and the lid can transfer back the heat to the battery. So I'm not sure if this is actually safe for the battery to run heats like this, or temperatures like this. Anyway, this is kind of like a sidetracking of what I was going to say. So far I found M5 Max MacBook Pro is the best hardware solution if you want to have a low power, smaller AI computer. As far as engine goes, I kind of feel like MTP-LX is okay because it's really pushing the machine to the maximum. But I was concerned about these high temperatures because even I was using fans and all that stuff, it was still going too high. So I think like the sweet spot is OMLX. OMLX is providing me with really good speeds. My benchmarking tool was showing that models, if I choose the right model, and you have to experiment a little bit and look around. So I downloaded a bunch of different models they were all like Quen 3.6 35B MOE model, for example, but they were giving me different accuracy results. So if you select the right model, you can get pretty good speeds, as I said, like 90, 100 token per sec decoding, and the prefill, wow. I mean, it goes up to like 20, 30,000. It rivals with the NVIDIA DGX Spark using VLLM, which is one of their strong suit, that it can provide really fast prefill speed. So yeah, so OMLX is the engine to go with. MacBook Pro, the M5 Max chip, as of May 2026. Yeah, definitely the best option that I've tried so far. As far as models go, I think the best way to deal with it, if you really want to do local inferencing, then you use the MOE model, the Quen 3.6 35B MOE model. You use that for the planning phase of building your project, and you use the dense model, the 27B dense model, for the actual making of it. And it doesn't really make sense what I just said, because the dense model is really good at complex tasks, right? So when you're doing the planning, the Quen 3.6, or actually you can do it the other way. Maybe you can do it the other way around, because I just wanted to save speed, right? Using the MOE model is super fast compared to the dense model, like 100 token per sec or 96 versus 30 token per sec. That's a big difference. So when you're working on a big project, then it really depends, like, are you going to be waiting hours versus, like, I don't know, minutes. So that's a big difference. So maybe you can go the other way, that the dense model could plan it out, and then the MOE model could actually implement it if you break it down into separate tasks. Because what the MOE model cannot do well, it cannot really do complex tasks, but it can work really well if you specify just one specific task. So either use a really good tool like RuCode for VS Code editor is a really good tool for breaking down the tasks and feeding it to the model one by one. Anyway, what was I going to say? So yeah, you have the two models, but you still have a problem, because then you have to load and unload the model constantly because of the context length. So the context window for these models are 262K, which seems to be a lot, but on a large code base, it's really not a lot. You have to be using smart tools that don't read the full files, such as RuCode. I mean, RuCode is definitely my favorite. I tried OpenCode. I tried different things, and RuCode was by far the best. Like, I mean, I literally tested like projects side by side, same code, same model. I mean, same instructions. Sorry, everything was the same. I was running it from OpenCode and versus RuCode, and it was a big difference in the quality of what it produced. So it also matters how you prompt the model, whether you're using code-based indexing, because RuCode is using code-based indexing, which is awesome. So basically you have to provide, and you can also run this locally. I actually have set up the GM Tech AMD Strix Halo computer. Sorry about the fire truck. So I'm using that computer for running a quadrant vector database. You can just install the Docker version, super simple. And then I'm running Ollama on the AMD Strix Halo with an embedded model, because when you want to do indexing, code-based indexing, you have to use an embedded model, not a regular model. This is a very small, specialized model that can feed the information like file contents or files into the vector database. So RuCode has this built-in feature where you can define the vector database, you can define the model that will do the embedding, and basically it indexes your whole entire code base. So when it wants to ask questions, it doesn't have to use like stupid like grep or whatever tools to find the information. It can go directly to the database, the vector database, and then ask it. And the answer comes back, and it's pretty accurate, no matter how big the database is or how big your code base is. So much more efficient. Open code, it doesn't have a built-in feature like this, but you can also set it up. I haven't tried, but you can also set it up just using MCP, sorry, getting confused with terms, MCP servers, because I think RuCode is pretty much doing the same thing. It's just like a built-in MCP server. And for OpenCode, you can just set it up yourself. You create the MCP server, and then you link and you give proper prompt to the model to use the server. So I'm guessing you could do the same thing, but it's not as obvious, and it's not default built into the model. So where was I? I'm pretty much getting close to the end. So yeah, as far as hardware, we already discussed. The MacBook Pro, the engine OMLX, I kind of feel like that's a sweet spot as far as like speed and stability. The model is definitely the Qwen 3.6 family, like no question about it. Like Gemma 4 is the only other competitor that can be run locally efficiently, and it's really good, but it's not as good as Qwen. I mean, I've tested them a lot, and one of the reasons why Gemma 4 is not as good as Qwen, because it's using a different architecture. It's using a sliding window, or whatever it's called, this feature. Then when it's reading large, like a lot of information, it has this small window that it can see from the code base, and it's moving this window. And as far as I understand, this is why Gemma 4 has this limitation, and it's never going to be as good as Qwen 3.6 unless either they extend this window to a larger number, or they just completely get away using this and just move over to what Qwen is using, which I forgot what it is, but it's something else. So yeah, the Qwen models are definitely, the 3.6 are the best. 27B, the dense model, is so good. I mean, I'm using models from OpenRouter too. OpenRouter is a provider where you don't have to like subscribe to individual providers. They have all the models. They have open source models. They have the big brands like ChatGPT, Claude, all that stuff. And you can just simply, just change the reference, which model you want to use, one API, and you just pay like $20, and you're using whatever models you want. For example, in my RuCode setup, I have there are these modes, right? So asking or architecture mode, and then coding mode, debugging mode. You can set up the perfect model for all of these modes. So if you don't want to burn too many tokens, then you just simply set something like a cheaper but still good alternatives. I'm using, for example, from OpenRouter, I'm using Qwen 3.6 Flash for creating the plan. So the planning, and if I want to ask question about the code base, I'm using that because it's super fast. I mean, I'm talking about like 220 token per sec sometimes. Super fast. And then if I'm using OpenRouter, I'm using the Qwen 3.627B dense model for coding, and it's really good. In my opinion, and based on my testing, it is actually better than Qwen 3.6 Plus, Qwen 3.6 Max, which is their proprietary, not open source model. They're available on Alibaba's hosting server, the 27B is really, really good. So my goal was like, what hardware can I buy so I can run the 27B model locally? Because once I can run that with, let's say, 100 token per sec speed, that's it. We reached it. We reached that. At that point, we would reach local AI is feasible, and local AI is at a level where it's full of quality, and you can use it for production. It's really good. Now, there's one more problem that we need to talk about. So we know what hardware is the best, in my opinion, as of May 2026. We know the engine, OMLX. We know the models. There are a couple more things. Within the model, there are features that you can, or you can get different models with different features, but I'm sure you've heard about it. There's D-Flash, P-Flash, speculative decoding, MTP, all this stuff. And my experience and what I'm noticing is that yes, you can get better performance under certain circumstances, but at what cost? Because the more you're using D-Flash and P-Flash and all these edge cases to try to fit a model and turbo quant and all this bullshit, yes, it allows you to run a model on a fairly not too strong computer with not that much VRAM, but at what cost? The quality, you're going to be suffering from the quality. Even when it comes to quantization of the model, I'm going with the best that I can, meaning like FP8, or when we talk about like the Llama CPP model, the Q8 version, right? The same thing pretty much. I kind of feel like that's the sweet spot for the Qwen 3.6 MOE model. When it comes to the 27B, if I want to run it locally, unfortunately, that's too big. So, unfortunately, I have to use a Q4 model. I cannot run the the Q8. So, once again, there is a quality degradation. So, I'm not a big fan of this D-Flash, P-Flash, speculative decoding, all this stuff. Because there is degradation in quality. Maybe the only exception is the regular, normal speculative decoding, such as the MTP, the built-in MTP feature, the flag. So with Qwen, supposedly, it's not supposed to have any quality degradation, although there could be a little bit. So if it's the built-in feature, which as of today, none of the big providers have full support for. So Llama CPP is currently working on making this available. OMLX on Macintosh has the feature. I can see the checkbox, but no matter what model I download, I cannot make it work. I just cannot turn MTP on. So I think in probably 2 months, these features will be part of all major engines like Llama CPP, OLLAMA, and all that other stuff, and it'll be working. And by the way, probably it's already working in OLLAMA because maybe that's why it was much faster. I'm not sure about that. But yeah, the built-in just normal speculative decoding could work. I'm not saying that's not an option. But overall, yeah, that's about the models. And there's one more thing I wanted to say about the context window. So when we talk about speed, what speed can I get with this model? Ooh, if I buy this hardware or I load in this engine or whatever, then I get 100 token per sec. Not so fast, not so fast. Because what's happening, and I built a tool for this to test it, is that at different context length, the speed will be different as well. So you start out, and as I said, I have this benchmarking tool that I feed in 4,000 tokens, and I keep feeding in more, 4,000 token more and more and more. And at each level, I measure the pre-fill speed, the time to first token speed, and also the decoding speed. And what I've noticed, for example, the decoding, which I care personally the most, is the decoding speed was about, let's say, 96 or 100 when it started with just 4,000 or 4K context window or context length. And then it started going down to all the way to even go down to 50 if you go all the way to the 200 and 62K context. So the speed really takes a hit. So once again, when we are talking about like, is local LLM or are local LLMs up to the point where it's completely usable, and you can just completely like cancel all your online subscriptions? And that's why I said, well, somewhat. Yes, you can run it if you want to wait a little bit longer, but you still have to have some compromises. So if you want to run the 27B model, which in my opinion is the best local model ever, then you have to use the Q4 quantization, which is not as good as the Q8, and you have to wait a lot, right? And one more last thing that I want to say, and then I leave you guys with this information, is the context length of a model. So I was very naively thinking like, well, Qwen 3.6, it says it supports 262K context window, so this is awesome. I can load in a big code base. Or as I'm coding, the context window is going higher and higher and higher. Based on my research, and I tested it a lot, as the context window is increasing, the model starting to hallucinate more and more. And I think right around the 120, 130K context length, past that point, the speed will also go down and the hallucinations start happening more and more frequently. So pretty much at every task that I have, what I'm trying to do is, and these are tricks and that I'm trying to figure out, is that I create the plan first using a model that fills up the context window, right? I create the plan that scours the code base, create what it needs to do. I come conversing back and forth to create the perfect plan. Then I save that plan into a file, the detailed plan. And then I start a new session, which has context window 0 at the point. And then I load in that plan file, and then I work from there. Instead of just continuing on, because let's say I'm at 100K context window, and I say, oh, I still have 162 to go. It's like, no, you don't. Because once you reach that level, that context window size, the model is not going to be giving you the right answers. What you're going to be starting noticing is that it will answer you, but it will give you the wrong answer. It will go in a circular logic. Whereas if you just start a new session and then you give the same question to the model, it will be able to answer properly. That's it. I think I just wanted to share all this so you guys don't have to go through all this on your own. You don't have to buy expensive hardware and spend countless months of testing. I hope you guys learned anything from this. And once again, I'm not a YouTuber, so please don't send me questions, or I really don't have time to do more than just releasing this video. So I hope you guys liked it, and yeah, happy local LLM. All right, bye.